Hi, I'm Lee Hayden. Welcome to this course on mental math. My purpose is to present a few basic techniques and to encourage your pursuit of more advanced techniques later on. Most people are surprised that these techniques even exist, how easy they are to learn, how useful they are in life, and wish that they had learned them many years before. In this presentation, the focus is going to be on multiplication of pairs of two-digit numbers. And our first example will be multiplication of a number by 11. So with that, let's begin.
Okay, you're going to marvel at the simplicity of the next multiplication problem. It's where we multiply a two-digit number by 11. Let's say take 23 times 11. Here's what we do. We take the 2 and the 3, we put it at the ends of what is going to be our answer. We add 2 and 3 and put the 5 in the middle, and that's the answer. Another one, say, 53 times 11. We put the 5 and the 3 at the ends of what will be our answer. We add 5 and 3, that's 8. We put 8 in the middle. That's the answer. Now let's look at, say, 82 times 11. 8 and the 2 at the ends. We add 8 and 2, that's 10. But we can only have a one-digit number here, and 10, of course, is a two-digit number. So here's what we do. 8 and 2 is 10. We put the 0 in the middle and carry the 1. And that gives us 902. Let's now consider a special case of squaring two-digit numbers that end in a 5. These are numbers like 15 squared, 25 squared, 35 squared, 45 squared, on up to, say, 95 squared. So let's look at that. We'll start off with 15 squared. 15 squared. Here's how we do that. We look at the first digit, add 1 to it. That makes it 2. 2 times 1 is 2. And we add 25 to it. Now that'll be the interesting thing about all of these numbers. They will always end in 25. So for example, 25 squared. We take the 2, add 1 to it, that's 3. 2 times 3 is 6. And we tap on 25. 35 squared. 3 plus 1 is 4. 3 times 4 is 12. Tack on the 25. That's what you have. Let's look at, and they're all the same. So we've just finished looking at cases where we took a double-digit number and that ended in 5 and we squared it. Now we're going to look at something that is somewhat related to that. For example, let's take a number like 28 times 22. We want to know what that multiplies to. First of all, we're going to notice that the leading digits are the same. In this case, they're both 2. And we notice that the trailing digits of each of the numbers adds to 10. And so that's a special situation. And here's how we handle that. We take the leading digit here, 2, and we add 1 to it, and that is 6. So we put down the 6. And now we look at the trailing digits, and that multiplies to 16. Okay, and that's that. Let's look at another one. Say, 82 times 88. The leading digits are the same, and the trailing digits sum to 10. So in that case, we take the leading digit, add 1 to it, and that's 8 times 9 in this case. That's 72. And 8 times 2, the trailing digits, is 16. That's how we do that. Let's do maybe 1 or 2 more. Say 45 times 45. That's just like squaring something that we did before, so we should get a familiar answer. But let's take the 4, we add 1 to it, that's 5. 4 times 5 is 20, and 5 times 5 is 25. Sounds familiar? One final one. Say 91 times 99. This is a kind of an unusual case. 9, add 1 to 9, that's 10. 10 times 9 is 90. 9 times 1 is 9, but we need 2 digits here. So we make that 0, 9. Okay. Previously, we had a situation where we had a pair of 2-digit numbers, and the leading digits of the 2 numbers were the same, and the trailing digits summed up to 10. Now we have sort of the opposite situation, where again we have a pair of 2-digit numbers, and in this case, the leading digits sum up to 10, and the trailing digits are the same. For example, let's take the case of 23 times 83. In this case, the leading digits sum up to 10, but the trailing digits are the same. Now, to get our answer, we start with the trailing digits. 3 times 3 is 9, but we need 2 digits over here, so this becomes 0, 9. And now we look at the leading digits. 2 times 8 is 16, and the commonality is 3. So 16 plus 3 is 19, and that's the answer. Another one, let's look at, say, 72 times 32. Again, the leading digits sum to 10, and the trailing digits are the same. We multiply the trailing digits, that's 4, and so again we put down a 0, 4 here. 7 times 3 is 21, and our commonality is 2, so 21 plus 2 is 23. Another case, let's make this 48 times 68. Okay, again, our leading digits sum to 10, and our trailing digits are the same. So in this case, 8 times 8 is 64. Put that down. 4 times 6 is 24, and the commonality is 8. So we have 24 plus 8 is 32. I'd like to talk now about more of a general way to handle the product of the 2 numbers that each have 2 digits in them. For example, maybe let's start with some definitions. This is a product of the trailing digits. These are trailing digits. And in this case, we have 2 times 3 is 6. And we always start with the trailing digits. Now let's look at what's called the inner product. The inner product is this, and the outer product is this, and we're going to be summing these two together. But let's look at the inner product. 2 times 2 is 4, and the outer product, that 3 times 3 is 9, and so when you sum that up, you get 13. Okay, so we put the 3 here and carry a 1. And now we look at the product of the leading digits. That would be this here. 3 times 2 is 6, and add 1, that's 7. And that's your answer. Okay, another one. We start off with the product of the trailing digits. 5 times 2 is 10. We put down the 0, and we're going to have to carry a 1 in this case. Now we look at the inner product. That's 15. The outer product is 8, and that sums together to 23. But we had a 1 to carry over, so we have 24 as a result. We write down the 4 and carry over the 2. Now we look at the product of the leading digits. 4 times 3 is 12, and we carry over 2, so 12 plus 2 is 14, and so that is our answer. We'll look at another problem that's